This is the video for a 2D wind tunnel simulation for Group 1 of Design of Aerospace Experiments lab for Wednesday. I'm going to show you how to set up the actual wind tunnel, and we're going to create this in SolidWorks. And let's get to it. So I'm going to click the front plane. We're going to start by creating a sketch here. We are going to make a line here that runs right through the origin of this. I have kept all this in CGS because we took our measurements in centimeters, so we're going to do that. What I want to do first is make this a midpoint. Actually, let me delete this. We're going to make this a midpoint line to start, and you'll see why later, because when we do are making lines later, we'll need it from the midpoint. We'll need the center of the origin in the center of our wind tunnel. So we make the midpoint line, and then we just draw a rough shape of our wind tunnel here. Right. And we took all of our measurements here. I'm just gonna dimension this out. And I'm doing this in half, and then I will mirror this over the line that I created first. The reason that came undone, but I'm gonna make that coincident. Now what I'm gonna do here, instead of having these rough edges, I'm gonna trim this, and I'm gonna make a line that's actually a tangent and smooth curve. So dimension that too, and dimension this as well. When we do that, it makes the simulation work a little bit better. So, all right, draw a line here. Double back on itself. Try and make a nice curved line here. And I make that half of that whole space. The whole space is 60, so that's like 30. What I'm gonna do is make sure, yeah, smart dimension there. Make sure that they are indeed tangent. But what I need to do is make this one and this one. I need to make that tangent. So you can see it makes a nice smooth curve, smooth transition between the two. So with this, we will mirror this across this line. Make a nice symmetric wind tunnel. The other thing I want to do is make this line here construction geometry. So it's not, I clicked all of them. Make that line construction geometry. So it's not actually part of the wind tunnel, but it keeps us in the center of all this. So makes it nice and easy there. So we have our rough shape of the wind tunnel here with our contraction chamber, our nozzle, test section, and the diffuser. So from here, while we're in the sketch, we'll go to insert here, surface and planar. So what that's doing is making this surface an actual plane. So it will turn out to be a little gray here. So from there, what we want to do is our sketch is done. So we'll file and we will save. When we save this, we will need to save it as an IGES. That is a format that Fluent will see and recognize, so it can use that. So I'm not going to save this because I already have one that's already saved, but that is what you will need to save it as. So after that's said and done, make sure you know where this is so you can import it into Fluent when you need it. So after that's all said and done, you can close out SolidWorks. I'm not going to save because I've already got this created. All right, so you go into the Fluent Workbench. I already have this preloaded, so what we need to do is create a Fluent project, and down here on the left, you got Fluent Flow. So we're gonna open this up, and you're gonna see a little box that shows up here, and what we want to do is right-click on Geometry here, and I would like to import geometry. Mine is saved as wind tunnel IGS. So import that into there. What I found is you need to still go back into this and edit geometry in Design Modeler just for Fluent to recognize it. If you try to proceed without actually loading the geometry in Design Modeler, it will not show up. It won't let you create a mesh for it. So while that is loading here, so Design Modeler is coming up here, and you'll notice there's an import here. At this point, what you need to do is generate from the import, and now our wind tunnel is in Fluent. So from here, all we need to do is close out of that because it is saved in there. And we'll go and create a mesh. Let's double click on the mesh. All right, the mesh is coming up. All right, I'd like to make it normal to the Z because this is in the XY plane. One thing to note is that make sure it is a surface body. This will actually be a whole body. If you did everything right by making it plane, then you'll have that. First thing we need to do is we need to label the actual edges here to make sure we have our inlet, outlet, and the walls. So create name selection here. As long as we name these properly, we will get the correct selection. So this is a velocity inlet. And this will be our outlet. And control click all of the walls here. Right click, name selection, and walls. All right, and over here, make sure we have them all labeled properly. All right, so once we've got that, we can generate our mesh. If you select mesh here, click the methods, select our geometry, which is the whole body, apply, we'll highlight all that. The other thing we change is to use triangles method to create the mesh. So once that's all done, we can generate our mesh. It looks like it created it. It is a very, very wide mesh. So if we come down to element size, for the purpose of this video, I'm only going to use 0.01. We used a much finer mesh in our project, but just takes a lot longer to run. So for this video, we'll do that. Since we changed the mesh size, we'll generate it once again. And it's still fine mesh, but it's not as fine as it could be. But for this video, we'll do this. So after that's all done, we are good to exit out of this. And right click the mesh, and we need to update the mesh in the project here. So all right, we got the green check mark here. I just want to double check something here. So geometry, one thing you need to check is your analysis type. Make sure it's selected to 2D, because if not, we are going to try to do that in 3D, and that's not what this project's about. So I actually need to update the mesh again because I did change that, but normally you would change that right before you update the mesh. So all right, we got the green check mark here. So now we'll go into setup. This is where it will be selected for 2D, so make sure it's in 2D. It is grayed out, so that's why you need to change it before you get into this. We are going to use double precision solver, and we're going to use two solver processes. So let's start, and this should bring up the actual simulation window. So right, looks like it's all done. As long as we named our inlet and outlet properly in the walls, then you should notice these arrows here of the on the wind tunnel. So first thing we want to do is we want to change the model that we're doing. First thing is energy. Double click this. We want the energy equation. And we want to change our viscous here to K epsilon. Verify that we also choose enhanced wall treatment and pressure gradient effects and thermal effects. And then hit OK. Double check your materials here. Fluid should be air. This is an air wind tunnel. And the other thing you want to check is your boundary conditions. So first one is your velocity inlet here. This is where we will set our velocity. This was calculated from a formula that was given to us, but then we had to convert it so it's the velocity at the contraction chamber, not the velocity in the test section. So roughly got 2.2946. This was in meters per second. So we are good there. Apply and close. Double check your walls should not be moving and should have no slip condition. So stationary walls, no slip. Should be defaulted as that, but if you changed it for any reason, I have not, might need to change that back. So we want to double check our reference values here. We are computing from the velocity inlet and our reference zone is surface body. Double check the velocity here is the velocity we entered in. Viscosity should remain this value, that is your standard viscosity there. And then the density is your standard sea level density of air too. They do not match, that needs to be changed back. So, but all of the rest of that is good. Then we go in and we initialize the project here. You will probably get a convergence error down at the bottom there. It doesn't mean anything right now. And then we'll go to run calculation here. We want to change the number of iterations. We used around 750 when we were doing the project. Probably we'll use 100 here, just for the sake of this video. And calculate. Now we'll run through the calculations. All right, calculations are complete. You can check this did not converge, so we used all 100 iterations here. This was the 30 hertz frequency when we were doing it, so the velocity even in the project didn't converge, but if we did the 10 hertz, it was converged. But this one also did not converge, so we are good to go though. The calculations are done. From there, we created contours, we need visualizations of the actual airflow here. So We're going to start with contours. We need to name our contours. We're going to start with the velocity contour. Changed our contour of velocity, it's velocity magnitude, and we're going to do it across all surfaces here, and we're going to save in display. And then we get our velocity here. So as we can see, there's no slip conditions, and because of the not very fine mesh, got pretty rough area around the outside. So, but that looks fairly good. We can play with the display and everything, which we made some nicer displays instead of this, but for the purposes of this video, I won't go through all of that. Another contour that we needed was the static pressure contour. Leave that static pressure, get the contour here. Static pressure again across all the bodies here. Display. So we can see our nice contour there. That's looking good. And also need another contour for total pressure. Again, changing total pressure here. Again, across all the bodies. Save that. That is looking good. Total pressure, stagnation pressure, which it should be the same throughout. So towards the walls it gets a little odd, but that's just because of the simulation here. So we'll go and make our final contour of dynamic pressure. So dynamic pressure, get across all the bodies, save display, and there we go. And that is looking good as well. Just as a note, because we did these smooth shapes or smooth edges around there, you don't see any transition issues. Sometimes if you make them sharp edges, the velocity will kind of get a little funky around sharp edges. So this is nice and smooth, so it gets nice and smooth contour through it. So that is good. The other thing we had to create was some XY plots. And we'll go and do that. Do it for all the same four, but we need to make one, or we'll have to do a vertical one here. This one's a little different. We have to do this, these XY plots across the center line. So we're going to have to create a center line first. So we did center line here. And center line is going to run through the whole thing at 0. This is why we did it at the origin. The origin's in the center of the actual wind tunnel here. So the center line is going to be half of the wind tunnel, but it's going to be negative the one that we created here. And it's going to be 5. So that's creating a line right down the center of this at 0, which is where our origin is here. So create that. Once we do that, we've got our XY plot. We're going to start with velocity here. And we got to name it something else. So, let's see, change this to velocity, velocity magnitude, and we're going to only do it across the center line here. For the purpose of the video here, this is what the plot is here. It's looking pretty good. The thing we had to do was write this to a file. So if we needed to write it to a file, we just check this and it would just put it into an XY file, and then we would open it in Excel, and that's where we created our graphs because we needed multiple graphs together for our 10, 30, and 50 hertz. So, but that's where we did that. We write the file and it would open it up, or we would open it up in Excel and then make our own graphs there. But this one is looking good here for velocity, so we'll move on. We need another plot for pressure. Again, static pressure, again across the center line, save and plot here. And it already exists because I didn't change the name. So name's definitely got to be different. All right, there it is. So we got our static plot here. That is looking good. Inverse of the velocity. So that is definitely good. Again, would write the file, but we're doing that for this video. And now we need a total pressure. And across the center line here. Total pressure, even though it looks like it's changing here, the actual values are very, very small. So you get very small differences in the total pressure, but it's essentially the same across the whole center line. All right, that is looking good. Need one more across the center line here, and this will be dynamic pressure. Right. And I need to make this plot. Again, across the center line. Save and plot, and this should be relatively similar to the velocity. So that is looking good. So that is all the plots across the center line, and we are also asked to do plots across a vertical line in the test section here. So we need to create another line for that, and we're going to call it vertical line. And this is going to be at 0. This is why we put our wind tunnel at the origin in the test section is at the origin. So our x can be 0. If not, you would have to calculate all this and just be a headache, and you don't know if you got it right. So, but ours, again, the height was at negative 0.76. And 0.76. All right, so we created a vertical line through the test section that we're going to use to calculate across. All right, once that is done, we need to make a velocity plot. Again, you got to call it something different. So call it vertical plot. First thing you need to do after naming it, we're going to plot it looking vertical, so it kind of looks more visually visually represents what is going on in the test section here. So I'm going to do position on the y-axis. Plot direction is going to be changed from x being 1 to y being 1. Again, this is going to be velocity magnitude, and we're going to do it across the vertical line that we created. So we're going to save and plot. And as you can see, it's running the other way, so it kind of visually gives you a look of what's going on in that vertical cross-section view of the test section, but that's looking good. You can see the no-slip conditions happening here towards the walls, so down at 0 velocity there, so that is good. So that one is done. We've got 3 more to make here. Go with static. Again, changing this to the Y. Up to 1 and static, and again across the vertical line, save and plot. So again, it's looking good there. All right. And now we have total pressure. Again, y-axis there. Now we're going to select total pressure and across the vertical line, save and plot. And that is looking good. And one last plot of dynamic pressure. And across the vertical line, save and plot, and there it is. It kind of matches up towards the velocity plot. So, all right. And that was all of the contours and the plots that we had to do for this. And on the project, we did each one of these, we labeled them 10, 30, and 50, and we brought them all together within Excel. And yeah. Oh, the other thing we had to do was to create or to find the pressure at the inlet of the contraction chamber and the outlet of the contraction chamber, which is the test section. So we'll get into that. All right, so from here, we've got all this. We're going to close this out here. So we want to save our changes. All right, and now we want to go into results here. Again, we want to look at this like we normally would. All right. So what we want to do is we want to make a contour here. Our location is going to be symmetry 1, and we are going to look at pressure here. What we need to do is we need to set a probe. So I'm going to click probe here. And we want to set this. Actually, first we want to, so some people have multiple numbers of contours here, 110, but just set it to that for this, and then we want to apply. Now we can do the probe here, and we want to go back to our Z view. All right. Now we want to select contour. So we select contour, we want to select the pointer, and then we want to select probe. And if we put a probe here around the center of the contraction chamber, we are the settling chamber, we will see we've got a pressure here. Now, this is gauge pressure. So we noted this pressure down. And then we also want to see our pressure here in, click probe again. So probe here in the test section. All right, I was able to get the probe now. So we've got our probe. It is set here. There is our pressure. We've noted this down. And then we can move this here. We moved it into the settling chamber. And that's where we've got our negative gauge pressure here. So that looks a lot better than before. But we can move this probe around. Kind of just need to keep it in the center away from the walls of each of these to get our pressure for both of those. And then with those points, we did that for the 10, the 30, and the 50 hertz, and took that and made a linear regression line in Excel for that. So, but that was the last thing we had to do for this project. So thank you for your time.